All right. Welcome, everybody, to our October meetup and office hours. So good to see so many people. So our agenda will have a little brief recap of gRPC Conf. That was the reason we didn't have a meeting last month, is because we had the big conference there. It seemed redundant. Everybody should know that there's going to be a gRPC maintainer talk at KubeCon. So if you go to KubeCon, make sure to go see that. If not, it'll be recorded and you can check out the recording. Then we'll have our presentation, and after that, the office hours. So a brief overview of the gRPC Conf. I don't know, you want to go, Terry, talk about it?
Sure, yeah. We had a pretty good conference. We had, as it says, 186 attendees, which was pretty good. We were shooting up to 200, so we did good. We had a bunch of talks, many external speakers, some from Google, but mostly external. We had a lot of breakout sessions where people started talking different topics amongst themselves. And we also had this meet a maintainer track where you could schedule up some time with a maintainer, discussions about issues you might be having or getting advice and stuff like that. It's pretty good. There's a link here for a playlist on YouTube. All the talks are recorded, and you guys can go and check that out.
Thanks. So going over, last July, we had gone over the previous several months' improvements. So over the last 3 months, we've had 3 releases, plus a bunch of patches, more examples, more user guides, a bunch of dependency upgrades, and lots of enhancements, bug fixes, and security fixes. A couple of things from the various languages. For Java, we stabilized 11 APIs and added support for Java 9 modules. Go is supporting the V1 reflection service and the least request load balancer. And Ruby's supporting client-side forking. So among all the various other things that have been done, lots of small stuff. And now on to the presentation. Sanjay, so why don't you take over?
Yeah, I can switch to that.
Just if you want to
I'm already sharing. It's there in the corner.
Oh,
We do it.
We probably want.
I think it's better if you exit and rejoin, Sanjay,
Okay.
because it'll pin it for everyone that way.
For the recording as well.
Okay. Now to find my windows.
Oh, so
well, you just need to share it.
I think that's a big O-in operation.
Okay. Okay. Cool. Hopefully everything works now. Hi everyone. My name is Sanjay Pujare. I'm a software engineer in the gRPC team at Google. And I'm going to talk about stateful session affinity in gRPC, specifically in the proxyless service mesh use case. So what I'm going to talk about is, first, I'll talk about what stateful session affinity is and why we need it, how we use it using cookies, and then there are a couple of aspects such as session draining and traffic splitting, which are relevant while you're doing stateful session affinity. I'll talk about the design and then implementation status, where we are currently. Then I have some sample code that shows how to use it from C++. Then I'll have maybe a couple of minutes for questions if you have any. Okay, so what is stateful session affinity? So in this slide, this is a conceptual representation showing the client, server, and the load balancer and the flow of RPCs between those components. So this is just to kind of establish the concepts of session and session affinity. What is happening is, let's say the client sends a first request. The first request goes through the load balancer. The load balancer picks server 2 as the server to send it to. Server 2 responds with a response. In the response, the load balancer adds a cookie. The cookie comes back to the client application. The client application copies the cookie in all the subsequent requests for that session. And the cookie, when it's processed by the load balancer is able to send those requests to the same server too, because it is doing stateful session affinity. So why would any application need stateful session affinity? So one use case that we are aware of is the backends they don't use shared state. They have local state, like I have shown it as like a disk, each server having its own local storage. So because they don't have shared state, typically when a client is creating a session and sending it, it needs to go to the same server. Otherwise, if it goes to a different server, that server won't be able to process it. And so that is one of the use cases of stateful session affinity. So when we were doing this and we were like, talking to some users who wanted this, they actually said ring hash or consistent hash doesn't work. And I have shown here why it doesn't work. So the way a ring hash load balancing works is, you get an incoming request, you generate a hash from the request. Let's say you take a header and create a hash from that header and use that hash to locate a server on a ring and use that server as the at the backend to send your request to. So in this case, let's say the request comes in, the hash value is 111, and on the ring, the closest server is 139. So we send it to 139. But now what happens if the set of backends changes and a new server gets added? And let's say that new server is number 115. What happens is the next request in the same session having the same hash value 111 will now get sent to server 115 because it's closer on the ring. That's the way the ring hash load balancing works. So because it goes to a different server, session affinity is broken, and obviously, the application kind of doesn't work. So what we need is, regardless of all these things, we somehow need to remember where we sent the previous request in the session. So if we could remember it, make sure that for a request in the same session next time, we send it to the same server. And how do we do that? Before I get there, I wanted to also, this is also something that came up during our discussions, is why is it important? Because people might say, okay, most of the times the backend set is kind of constant. It doesn't go up and down, but there is one case where it happens quite commonly. One is in Kubernetes. Kubernetes has a feature called auto scaling, where, as part of capacity management and resource optimization, Kubernetes can add or delete pods. So based on traffic or usage of resources. So you can configure it so that, the resource usage or the traffic can be an input in the auto scaling process, and that auto scaler can then add or remove pods. So in this case, let's say on node 2, the Kubernetes node 2, there is a pod n, which has some assigned sessions, but Kubernetes autoscaler decides to remove pod n as part of its downscaling. And if that happens without any kind of a advanced warning or any kind of a coordination with the stateful session affinity, then you lose sessions and the applications kind of get impacted because session affinity is broken. So So in use cases like this, we actually want stateful session affinity because not only that you do sessions, but the ring hash load balancing will also send requests to a different pod. Okay. Now, it is obvious that we need a stateful load balancer, which kind of maintains a state. So one way to do this, a very simplistic way, is the load balancer maintains a hash table and it maps, let's say, a session ID to a backend address. So let's say the incoming request has a header, session ID or something. You get the session ID from that header, map it to a backend address, and then use it to send it to the correct backend. And this is stateful, and so that doesn't get impacted by change to the backend set. Now, this is stateful and it works, but the problem is the hash table is a overhead on the load balancer. The amount of memory required is proportional to the number of sessions it has to maintain. And the second problem is it has no way to actually garbage collect entries from the table because typically the load balancer won't be application aware. So when sessions end, it wouldn't know, so it wouldn't know when to remove entries from this table. So the table would just keep on growing. So that's where the idea of a cookie-based stateful session affinity feature, we thought of it. In this, basically, the load balancer, sends the first RPC in a session using the configured load balancing. When the response to that RPC comes back from the server, it creates a cookie and puts a cookie in the response. The response goes back to the client application. The client application copies that cookie in all the subsequent RPCs in that session. And the load balancer uses the cookie. It extracts some information of the cookie and uses that to route those RPCs to the same backend that the first RPC went to. So we have effectively a stateful session affinity, but the state is not maintained inside the load balancer, but is maintained inside the cookie, and the cookie is maintained by the client. So we kind of don't have to maintain the state inside the intermediate layer, which is a load balancer or a proxy or even the gRPC library. And that's the beauty of it. So let's see how this works inside gRPC. So gRPC is a library which is part of the client application process. The client generates or sends the first RPC. It goes through the gRPC library, and gRPC library will do load balancing and send that first request REQ1 to server 2 based on the applicable load balancing algorithm. So server 2 processes the RPC, sends the response back, RSP1. gRPC will receive it, and because stateful session affinity is in effect, it will mint a cookie, put that cookie in the response, and send the response back to the client application. The client application keeps using that cookie for all the RPCs in that session. The cookie is used by the gRPC library. The gRPC library extracts a cookie, uses the information in that cookie, and uses that information to route those RPCs to server 2. And so that's how we maintain a stateful session affinity. So when we were kind of designing this and doing it, the user who wanted this also told us about this thing called session draining. Now, the thing about session draining is, I talked about Kubernetes removing pods, right, as part of its auto scaling or downscaling. Now, if it just willy-nilly removes a pod, we could lose active sessions because that pod was responsible for serving requests of that session, and Kubernetes just removes it, then it's kind of affinity is broken. So we came up with this thing called session draining, where what happens is, with some coordination with Kubernetes, Kubernetes doesn't remove the pod immediately, but it puts the pod in what is called a draining state. So when a pod goes into a draining state, only RPCs of existing sessions for which that pod is responsible are sent to that pod, but no new sessions are created on that pod, right? And that is what draining means. Because we are draining that pod, the sessions will slowly drain, and when all the sessions are gone from that pod, the pod will be reclaimed by Kubernetes. So that is what we call session draining. And how do we make it work? We make it work with some integration with Kubernetes. So what happens is Kubernetes has this feature called termination, pod termination with terminating grace period. So what happens in that is we register something called a pre-stop hook for the pods of interest. And when we register a pre-stop hook, whenever Kubernetes is about to shut down a pod as part of its downscaling, it won't do it immediately. It will first create this stop container event, which causes the pre-stop hook in the server application to be called. Now, the pre-stop hook is like a signal handler in a C application running on Unix. So I think a signal, let's say a SIGTERM handler, is the one that gets invoked when the OS is about to terminate the process. The SIGTERM handler will do whatever it needs to do to clean up stuff. And when it returns at that point, the process will be actually terminated. Similarly here, the pre-stop hook, when it gets invoked, in our use case, the pre-stop hook actually has access to the application and the sessions in the application. So the pre-stop hook actually remains keeps running and kind of is blocking until there are active sessions in that backend. Only when all the sessions are gone, the pre-stop hook returns. And when it returns, Kubernetes goes ahead and actually terminates the pod and reclaims that pod. One thing to remember is there is an upper limit, which is called terminating grace period. So if the pre-stop hook doesn't return before the grace period is over, Kubernetes will forcibly kill that pod. But in our case, hopefully that shouldn't happen. The other thing that we kind of had to deal with when we were actually, trying to make this use case work is the case of traffic splitting. Now, what I have here is a configuration fragment using Gateway API to show traffic splitting, where I have a service called Hello World, which is being split into different clusters. So I have version 1 of that service, which is running on cluster 1 called V1 Hello World. Version 2 is running on cluster V2 Hello World. And I have created a traffic splitting snippet to split traffic 10% and 90%. 10% goes to V1, 90% goes to V2, right? So with this, let's see what happens, how it impacts stateful session affinity. In this case, let's say the client application sends a first request, REQ1, and the load balancer picks cluster V1, and sends the request to that one. On the response side, the load balancer will create a cookie, and in the cookie, it will put the address of the backend in cluster V1 and send it back to the client application. Client application uses that cookie correctly, but the load balancer now uses traffic splitting we have, and because 90% are supposed to go to cluster V2, most likely the requests will go to cluster V2 and session affinity is broken, right? So we kind of ran into this situation, and the solution was kind of simple. What we kind of decided to do is the cookie should also encode the cluster name, and the load balancer would give priority to the cluster picked by the cookie instead of the cluster picked by the traffic splitting. And so with that, we maintain session affinity, even though there is traffic splitting going on. So we actually implemented that too. So I think I just have one slide to describe the design because I didn't really want to go into the details of the design. So within gRPC, we have something called a config selector, which is the first thing that kind of, when an RPC comes in, that's the first thing that processes it. So that one selects a cluster. It also invokes the HTTP filters. So HTTP filters are filters which work on an RPC and does HTTP level manipulation. So things like processing the headers and all that stuff. So we have this new filter, HTTP filter called stateful session filter that is added to the filter chain. The job of that filter is to process the cookie header, extract the host information and the cluster information from the cookie, and set two attributes called override host and override cluster. These attributes are then passed down the load balancer hierarchy. There is a new load balancer called XTS override host, which is responsible for looking at those attributes and using those attributes to then properly send that RPC to the cluster and the backend pointed by those attributes. So this is at a very high level, this is the design, and there are so many other things I have left out. But this design has been implemented only in C++ currently, because that is what our users wanted at that point. If there is any demand, if anybody wants this feature in other languages, we'll schedule some time and do it. So that's the implementation, the design and implementation. So this is sample code, how to use stateful session affinity. So, there is a cookie object. That cookie object is used in that first call, greeter.sayHello. The first parameter is the one that gets the cookie from the first RPC. So the say hello takes two arguments. First is a cookie received from the so-called server, and the second one is a cookie to send to the server, right? I mean, I use the word server, but actually it is going to be processed by the gRPC client-side library itself. But from the application point of view, it looks like it's going to the server or talking to the server. So anyway, the inside the loop, the say hello actually uses the second argument because that's the cookie that is used to send RPCs out. And so this is a very simplistic like code snippet that shows how to use it. And I have actually the say hello function here that shows how it is used. So if the cookie to server parameter is set to a non-null, then it is used to add the cookie to the metadata, request metadata. It is added to the context, and then we actually make the call, say hello, using the stub. And then there is a bunch of code that I don't have here, but assuming that code is processing the response coming back, then if the status is okay, and if the first parameter is set or non-null cookie from server, then we get the cookie, extract the cookie from the response metadata, extract it and set it to cookie from server so that the caller actually gets the cookie. So this is the code snippet. I just have, so we created a couple of designs or design documents as gRFCs. First one is A55, which covers the basic stateful session affinity and then session draining that we implemented. And then we kind of decided that we needed to enhance it and also add support for traffic splitting, also called weighted clusters. We added support for that, and that design is described in A60, the gRFC A60. So that concludes the presentation, and let me know if you have any questions. Yeah.
Does it work with round robin? Yeah.
No, I mean, the first RPC can use round robin.
Yes.
But after that, if the cookie is used, then none of the other load balancing policies would actually use. It'll just use the cookie. to route it.
And round robin is working with the gRPC thing, right?
Yeah, I mean,
There's
so,
expected behavior.
yeah,
Just the fact that the cookie comes from the server means this will be enabled automatically, or do you have to? do
oh,
something?
no, oh, so one thing I didn't talk about is it needs to be configured from XDS. So only when you configure it, so enable it, then one of the slides I have here talks about Istio, right? So Istio will actually create the appropriate filters. Let's say HTTP filter I talked about. Those HTTP filters are injected into gRPC, and then gRPC, only when that filter is active, will do all of the processing I talked about.
The server needs to return the cookie and the filters need to be installed.
Server being the Istio server, not the backend server. The backend server is completely oblivious. It doesn't even know about what is going on. The server is not even processing the cookies. The cookies are present in the RPC that the server receives, but it's not expected to do anything with it.
Where's the first cookie generated? Who's responsible?
gRPC generates it. gRPC, the library generates it. So the application thinks it came from the server, but gRPC inserted the
It's
cookie.
in these header.
Right, exactly. I mean, the filter and all that filter and the load balancer, they do the magic and then put the cookie. Yeah.
Yeah, it looks the same whether or not you were using sidecars or not.
Yes, right. Oh, that's another thing. So the way the feature is implemented, it was originally implemented by Envoy using the same XJS configuration. So we just kind of piggybacked on it and use the same thing. So if there were a sidecar instead of gRPC, the sidecar would inject the cookie and send the response back to the application.
And if you paired it with round robin, then you would get round robin, but it would round robin the sessions.
Yes,
So each backend would get the next session.
yeah, exactly.
Here, the sessions, we mean the streams, the
Mm,
properties, you know.
It's multiple RPCs, so it doesn't have to be a single stream.
Session is a concept of an application. Application decide. So it's like, when I log in as a user, the web application creates a session for me. So every activity I do within that session becomes part of this session and goes to the same backend.
It's the application decides
Yeah.
how to decide each session, not gRPC.
Yeah, gRPC doesn't. So application decides the session by copying the cookie appropriately. And the same application can create multiple sessions too.
So how does Kubernetes know that the session is complete?
Kubernetes doesn't directly know. So this one, the pre-stop hook I talked about.
Yeah.
The pre-stop hook just returns. So when it returns, Kubernetes gets the signal or whatever to know that, okay, whatever was blocking me from shutting down the pod is done. So I can now shut down the pod.
Where's the,
So this means the server needs to know explicitly when a session is over.
Yeah, that's true, actually.
And so if the client were to use the cookie again,
That's
then it wouldn't work.
Actually, that's a very good point. So in the use case that we were dealing with, the server actually knows. So it's something like the login signal and the logout signal. So client actually sends a logout saying, okay, my session is over, and the server knows it can remove that session from its.
where's this hook implemented? Who implements that?
Which hook?
This shutdown.
Pre-stop.
Pre-stop hook.
So pre-stop hook, there are two kinds of pre-stop hooks. One is an HTTP callout. So let's say HTTP callout is in your application, you just host a small a web server, HTTP server, and Kubernetes will make HTTP call to it. So I think it's a get or whatever, right? And you just don't return
But it's the
until
server's responsibility.
it's the server's responsibility, right?
And then they configure. it.
Right.
Okay.
The other one is, I think, just a command. So it's like a shell command or whatever. So it just, the Kubernetes will just execute a command. And the command could be something that we wrote, right? And that command could be a gRPC call into the server application, I think, which is what we have done. So our server can decide, okay, I'm not ready to execute yet, so I'll just block for another 2 minutes.
So the user needs to know to do this specifically. I'm just thinking of the users, they need to put the hook in
Yes.
place.
Yeah.
They need to implement the hook
That they have
themselves,
implement the hook, right?
right?
Right.
Then they need to put in, what was the other thing you just said? They need to know when the session ends.
That's right.
So that's.
That is the application logic.
Yeah.
So the
Perfect.
pre-stop hook has to be kind of tightly integrated with the application logic. And it needs to know the application, the server application has finished processing all the sessions. So yeah, the pod can be shut down.
Yeah, just to understand if I wanted to implement this, what do I need to do? Those two things on the server and then XDS, the control plane with the client.
Let me see if XDS you need to do anything. I don't think in XDS you actually need to do anything for. Oh, well, XDS.
The filters need to be configured.
Oh, that is for basic stateful session affinity. I thought you were asking about session draining. Yeah. So overall,
The
yeah,
whole thing.
whole thing, right? Yeah, that's true. You need to make sure those filters are kind of sent by the XDS thing, and then
Opens and, right.
correct.
Which the session draining is optional. That's a further optimization the application can do, right?
That's right. So when you say optional, meaning somebody doesn't care about it, they don't really want this. Yeah.
Everything's in their application there, so they can simply not do it if they don't want it.
So what's the worst thing that can happen if we don't drain them?
Oh, then some applications, the client applications might suddenly see that they are not able to like communicate with their designated backend because the sessions that they have were handled by that backend, that pod, and that pod just shut down. Right.
Which the simplest model for this would be to just say that each client has their session. And think about like a web browser session or whether you're like in a closeout. You know, back in the old days where we would close out our windows at the end of the browsing. And so this was sort of, if you view like a web browser model, they click login, all their information is on that one server, it's efficient. So even if they're sharing databases, it might be more expensive to migrate that storage across the backends. So you pin that client
Yeah.
to one backend for a longer period of time. And if it's less costly, you know, you don't want to migrate all the time, but if this server went down, you can just hit another server and migrate the
Throw away the cookie, say this doesn't work anymore, and then you get a new session.
You would keep your cookie whenever you send that RPC and that backend is down, the reply will have a new cookie in it.
Oh, I see.
And so then you would continue using that new cookie.
The filter knows what's
Yeah.
going on and. will give
Actually,
you
that's
a
true.
new-
Yeah, I didn't cover some of these details. One more thing I didn't cover is the draining stuff. There is a new state for the endpoints in EDS called draining. So endpoint in EDS can be healthy, unhealthy, and draining. So it was always there, but we actually now use it. So when a backend is in like this particular state, the corresponding EDS state for that endpoint is draining. So the load balancer knows not to send
No
new
more.
session RPCs, but existing ones, if a cookie is pointing to it, it is okay to send.
Thanks.
Okay. Any questions from non-Googlers?
I see several of you there, so, you know, feel free to unmute and ask a question.
Okay.
Okay, so now that our presentation is complete, we can move on to office hours. So we did have one question that was asked previously where it was posted in gRPC.io, asking a question. Unfortunately, I've not been able to get a response for that yet, so we'll continue pursuing that and get back to you on it. But do any of the other people here have questions that we can help with?
Yes, I have a question.
Great, Conrad.
I was wondering if there's like a matrix which basically shows the user coming from the outside in terms of like what features should exist and in what language.
So the question is, do we basically have a per language list of features? For any feature that is implemented in multiple languages, we go to great pains to make sure that they can interconnect. So it's really just a question of, does the feature exist at all in the language you're interested?
One thing we've been trying to do is on gRPC IO, if you go to the documentation portion of it, and there's a subsection guides. We've been trying to fill in all of the major, what we would say, features that we support across the major languages, that we have a bit of a guide there, 1-2 pagers. So that's a good catalog for you to look at. We're still missing a few, but that gives you a list of the most important features at least. And then in those documents, you'll have links to examples to different languages. And often we mention there, oh, this is not implemented in this language yet. So
So Terry, let's have you post a link directly to that on the meetup as a comment to today's.
yeah, sure, I can.
Yeah,
Larry can help do that, but then everybody can.
yeah. So this is what gRPC.io, looks like as the main site, and there's a docs link that takes you into the documentation.
The guides are.
One other thing I'll add is, we, absolutely, if there is a missing feature, especially if it's implemented in another language, please let us know. So, for example, Sanjay mentioned that, stateful session affinity, we only have access in C++, but for sure, if someone was wanting it in other languages, we would jump on it right away and deliver that out to the community for folks to use. I'm sure we'll get to it eventually, but right now, we've got a ton of different priorities and things that we're working on. And we also want to make sure, we're working with a group of developers right now who are using it or who will be using it soon. And we're wanting to get a bunch of feedback from them, verifying our designs, verifying it works well before we do it across other languages.
Yeah, and in each of these guides, we do have links to actual examples in the various languages.
Which if the language is missing, that doesn't mean it doesn't necessarily have the feature, because we're fleshing out the support cross language. But some of the I think a few of these, we say the feature explicitly is not available in that language.
Yeah. I'm not sure which of them they are, but yes.
At least to the question, Sanjay, should we have a user guide for this particular feature? Does it make sense in this list?
Yeah, I think it's probably a good idea because we did describe the feature in our CSM user guide. So yeah.
I
So
can make a book for it.
For XDS features, there's also the document in the main gRPC repo under the doc directory that lists all the versions and all the features in a matrix, or sorry, all the languages and all the features in a matrix. And then it says what version, if any, support was added for each feature in each language. Those are for XDS specific feature.
Yeah, I posted a link to that doc in the chat a few minutes ago.
Oh, okay.
Because there's just so many features in the XDS, like little itty bitty knobs on the messages and stuff.
Doc gRPC XDS feature.
Right here, this one.
gRPC XDS features.
Start with a G probably.
Yeah.
Everything's.
And there's a matrix down there if you scroll.
Okay, so yeah, so here's an example, Conrad.
Great. Thank you for the answers, everyone.
Yeah, thanks for the question. That was great. So Noel or Raceman, do either of you have something you'd particularly like more information about?
Nope, nothing on my end.
Okay. I may have missed somebody else that's external. If so, please feel free to ask a question. It's much more fun when you have questions.
True.
gRPC
newbie. Good to go.
Oh,
All right.
great. Welcome. All right. We are not going to have anything November, December because of the holidays, but we will pick up again in January. And if anyone has a topic they would like to talk about, please feel free to contact me. On the meetup, there's a link, or you can email me directly, lsafran@google.com. Okay, thanks very much. Bye.